Okay, so I appreciate you guys hanging in with me through all of that vocabulary we did through 5.1 through 5.4. 5.5 and 5.6 are almost like a break from that because the concepts here are a little more applicable in different situations, more realistic situations, and I think the vocabulary is a little bit easier to understand. So we're going to talk about inequalities in one triangle. So what we're going to do today is we're going to list sides and angles of a triangle in order by size, and we're going to find possible side lengths of triangles, which I think is important to understanding how triangles operate. So the first theorem we're going to talk about is the triangle longer side theorem. And what it states is that if one side of a triangle is longer than another side, then the angle opposite that longer side is larger than the angle opposite the shorter side. So if you look at AB, we can tell that AB is longer than BC, which means that angle C is bigger or larger than angle A, because angle C is across from a longer side. Okay? On the flip side, if one angle of a triangle is larger than another angle, the side opposite the larger angle is longer than the side opposite the smaller angle. So since angle A is greater than angle C, or larger than angle C, that means that BC is longer than AB. So that term opposite, you have to know what I mean when I say the term opposite. We're going to get more examples of that. So in example 1, ordering the angle measures of a triangle from smallest to largest. So looking at this triangle, the smallest side is BC because it's got a length of 11, which means the smallest angle is angle A because it is opposite from BC. Okay? The second smallest side is AC because it's 12. The angle opposite from AC is angle B. So listing these from least to greatest, A, B, then C, because A is opposite from the shortest side, B is opposite from the second shortest side, and C is opposite from the longest side. That's it. For example 2, ordering the side lengths. So now, before I do anything, I want to know the measure of angle F. And we've done tons and tons of examples of finding the third angle in a triangle. You simply just take 180 minus the two known angles to find that unknown angle. So 180 minus 51 minus 47 is 82. So angle F is 82 degrees. So the smallest angle is E, which makes the shortest side DF, because it's opposite from the smallest angle. The second smallest angle is D. The side opposite from that is EF. So that's the second longest side. And then the longest side is across from the largest angle. The largest angle is F. The side across from that is DE. So that's it. Just listing sides from least to greatest or angles from least to greatest. Just remembering, the longer the side, the larger the angle. The smaller the angle, the shorter the side. So some guided practice here for you to pause the video, check your answers, and move on to the next examples. Okay, so pretty straightforward. In the first one, those look like L's. Sorry. Angle Q is the smallest, then P, then R. In number 2, ST is the shortest, then RS, RT is the longest because it's across from the largest angle. So moving ahead, we talked about how to order the sides and angles in a triangle. The triangle inequality theorem is an important theorem because it talks about how we build a triangle. So the sum of the lengths of any two sides of a triangle must be greater than the length of the third side. So any two of the sides their sum has to be greater than the length of the third side. So to illustrate that, we're going to cover example 3, where we're given two sides of a triangle, and we have to find the possible lengths of the third side. So let's just say this is triangle ABC, and this is not to scale at all, so don't read into this at all. Okay, let's just say that AB is 14 and that BC is 9. We have to find the possible lengths of that third side. So the possibilities are this third side could be basically two extremes. It could be the longest side or it could be the shortest side of this triangle, all right? So if AC, just in my head, if AC were the longest side, it would have to be less than the sum of the other two sides. So AC needs to be less than the sum of 14 and 9. So that means that AC has to be less than 23. Okay, AC has to be less than 23. That's one possibility. The other possibility, if AC is the shortest side, that makes 14 the longest side, which means that AC plus 9 would have to be greater than 14, because the sum of any two sides has to be greater than the length of the longest side. So AC would have to be greater than 5. Okay? So our possibilities, and this is how we write this inequality, our possibilities for AC, it has to be greater than 5 and less than 23. So this is the inequality I write, which represents AC has to be between 5 and 23. It can't be 5, it can't be 23, it's got to be in between those two lengths. So what you're thinking about is that your third side, there's two possibilities. Your third side that you're finding the possibilities for could either be the longest or shortest side. So essentially, you're adding the two given lengths together. That's the limit for the longest side. You're subtracting them. That's the limit for the shortest side. So as far as guided practice goes, I want you to do number 3, and then I'll go over 4, 5, and 6. So just focus on number 3. I'll go over 4, 5, and 6 with you. Okay, so for this example, AC has to be between 8 and 32. It's got to be greater than 8, but less than 32. So if you're confused about writing the inequality and you get stuck, you can literally write AC has to be greater than 8, but also less than 32. So it's got to be in that range. So in examples 4, 5, and 6, it says, decide whether it's possible to construct a triangle with those given side lengths. Essentially, all you do to figure out if the 3 side lengths can construct a triangle, you add together the 2 shortest side lengths. So 4 plus 9 is 13. And you're determining if that sum is greater than the longest side length. 4 plus 9 is 13. That sum is greater than the longest side. So yes, it's possible to construct a triangle, because we talked about the sum of any 2 sides has to be greater than the length of the longest side. And really the only test you need to make is that the shortest sides have to add to be greater than the longest side, because I know that 9 plus 10 is greater than 4. Okay? I know that 4 plus 10 is greater than 9. I'm just testing if the shortest 2 sides sum to be greater than the longest side. So in number 5, I'm going to add together. The shortest 2 sides is 17. 17 is definitely not greater than 18, so no, not possible. So the sum of the 2 shortest sides cannot be less than the longest side. And then for number 6, 5 plus 7 is 12. So this is interesting because it's equal to the longest side. That is not possible, because we talked about the sum of the shortest 2 sides, or the sum of any 2 sides, has to be greater than the length of the longest side. 12 is not greater than 12, so it's not possible to build a triangle like that, because if you think about it, if I stand a 5 and a 7 centimeter long segment end on end, it would be equal to the length of a 12 centimeter segment, which I can't build any sort of triangle. I can't create any sort of angle that creates, a figure, a polygon, because 5 and 7 are the same length as 12. This length needs to be more than 12 to create any sort of shape, okay? Because they're the same length, cannot create a triangle from that. So you should be ready for some practice on this topic. Just pay attention to some of the wording because it's important to know how to order the sides and angles in a triangle and to find out the possible lengths of a triangle.